Okay, last installment of Chapter 17 are just 3 practice problems. First one, they want you to calculate KEQ, and they give you the reaction. We have pure solid on the left, we have a pure liquid on the right, so the only thing that we need to do is set up Kp is equal to the partial pressure of oxygen. Now, if they want, given us thermodynamic values, the only relationship that we had that involved K was negative RT natural log of K. So we solved that for natural log of K. And the problem is they didn't actually give us delta G naught, so we're going to have to calculate that, which is annoying. So to get delta G naught, do the Gibbs equation, and for delta H, we only have to worry about the mercury oxide because the elements have a value of 0. You don't have to document it. And for delta S naught, those elements do have a value of 0. Now, when I was doing this problem, I noticed, and I would have said this in a regular class, that when there are slight differences in sig figs and the way they're applied, there are actually large differences in the final answer. So my answer is slightly different than theirs. Once I got delta S, I converted it to kilojoules per mole Kelvin and then substituted that back into delta G, Gibbs equation, to get delta G naught at 117 kilojoules per mole reaction. Then I can go back and substitute it into Kp. But again, they got 2.9 times 10 to the minus 21. I got 3.2 times 10 to the minus 21. That has to do with the way the sig figs were applied. And they're very flexible on that sort of thing on the AP exam. So far as I'm concerned, we're good. On the second problem, they give us Kp and they ask us to calculate delta G for the conditions. So they're implying a Q here because they're giving us concentrations that we know are not going to multiply out to be 1.78 times 10 to the minus 10. So the equation would be delta G is equal to delta G naught plus RT natural log of Q, but they didn't give us delta G naught. So we're going to have to figure out delta G naught. And we can do that by substituting into negative RT natural log of K. I went ahead and set up Q. KSP for silver chloride is silver times chloride. And they give you the little dissociation equation there. So we can just do silver ions times chloride ions. And I substituted in the values they gave me. Now, I don't think they meant for it to be 1 sig fig, but I wrote 1 times 10 to the minus 6 anyway for Q. And then I went back and substituted that into delta G naught is negative RT natural log of K. And I got 55.6 kilojoules per mole. And then from there I can just substitute it into delta G naught plus RT natural log of Q. And I got what they got, 21.4 kilojoules per mole. Now the last one is interesting. They asked for delta H naught of formation for bromochloride. That's important here because they're not actually giving you the values for delta H of formation. They give you the delta G for that condition, and they give you the entropy values. So normally we'd say, all right, delta G is the Gibbs equation, delta H minus T delta S. We can solve that for delta H, which I did over to the right. I have to calculate the delta S values, which I did, products minus reactants, and then converted it to kilojoules per mole. And then I substituted that in for delta H. So we did delta G plus T delta S, and we get 29.3 kilojoules per mole reaction, which is double what their answer is, but this is the key to the question. For delta H of formation, it's 1 mole of the compound. They gave you the reaction for 2 moles. So delta H of formation is going to be equal to delta H for that reaction divided by 2. And that's where we get our 29.3 kilojoules divided by 2 gives you 14.65, which we round down to the even number. So we get positive 14.6 kilojoules per mole reaction. Okay. In fact, I wouldn't even put a per mole reaction on this one because by definition, it is defined as 1 mole of the product. But that was the trick in this one. Other than that, it was pretty straightforward. And if you're noticing on these problems, they're just tedious. They're not hard. They're just tedious and annoying. And but as long as you have your little formula sheet there, because all of these equations, the Gibbs equation, the delta G equals negative RT natural log of K, the delta G naught equals that, delta G equals delta G naught plus RT natural log of Q. As long as you have those equations in front of you, you should be able to utilize them and substitute in. So should do well on the Chapter 17 stuff. All right, so again, just go through and pause where you need to pause to take your notes. And good luck with everything. Take care. Good night.